welcome back. In this video, I want to pick up from where we left off last time, and you may remember we talked about different ways to calculate concentration. So we talked about mass percent, we talked about mass volume percent, and we talked about volume percent. And those concentration units have different uses in different areas, if you remember. In biology, we oftentimes, for example, use volume percent, and a great example of that would be a saline solution, or even maybe a 3% volume for volume solution of hydrogen peroxide, which we use in first aid kits. It's also an antiseptic, and I have it in the chemistry lab as well. The last unit, if you recall, that organic chemists and inorganic chemists tend to use the most is molarity, or moles per liter. And that's the unit that I want to focus on here. And we're going to go through the steps required to make a solution. And I know I talked a little bit about the volumetric flask the other day, and we'll follow up on that. So here are the steps that you would take if you were going to step foot in the lab. Clearly my students would be doing this right now. I would have you go to the back storeroom in the chemistry lab and find a chemical that needs to be made up and go through the steps to make it. So in a sense, I would typically make you my little lab rats or lab technicians, and you would learn on the job. But you'll have to deal with our confines in my confines, I should say, in my house, and we'll just imagine that we are in the lab making these solutions. So here are the steps that we want to go through. Obviously, as a chemist, we typically need to have a good supply of solutions on hand. In our science department, I'm typically the one that makes those up. And I always label my solutions. You should always label what they are, what's in them, and what is the concentration. Well, we refer to those solutions as either standard solutions, which means they're very accurately produced, or stock solutions. And they're usually a little more concentrated than the solutions that one may need in a chemistry class or a biology class. And so when we run out of stock solutions, I'm normally the guy that makes them up. Or maybe you would be in my grade 11 or 12 chemistry class. So let's suppose that we're going to be tasked with making a solution of cupric nitrate, copper 2 nitrate, beautiful blue compound. When you put it into water, it's quite lovely. So let's suppose that somebody says to you, go ahead and make me up 250 milliliters of 0.5 moles per liter, or molar, cupric nitrate, or copper 2 nitrate. What do you do? Well, the first step is to do the math. You have the molar mass, because you have the formula, and we go back to our solution triangle, our new mole triangle. Notice that I put N on the top. Not to worry, moles is N. So when you see N, you'll know that we're dealing with moles. Concentration is in moles per liter, and volumes in liters. So simple calculation, we find our moles first. That's concentration times volume. The concentration of our stock solution we're going to make is 0.5 moles per liter. And in this case, our flask is 250 mils, or 0.25 liters. Cancel out your units, we end up getting 0.125 moles. This seems quite familiar. We can't weigh moles on a scale. You may remember that from earlier discussions. So we have to convert moles to mass. So that's our second step. Find the mass of the cupric nitrate that you would have to weigh on the scale. You've been there, you've done that, you won the t-shirt. Grams equals moles times molar mass. We have our moles, 0.125. The molar mass of cupric nitrate is 187.6. Don't trust short chemists. That's me. Do the math on your own. Use your table and your calculator. You will get about 23.45 grams of cupric nitrate. Now you're ready to grab the bottle of cupric nitrate, which is in the back storage room of most chemistry labs. Get yourself a weighing boat of some sort. That's just a little plastic device that you can put on the scale, and carefully add your cupric nitrate till you hit that number, 23.45 grams. Maybe your balance weighs to 1/1000th of a gram. You might do better than that. Finally, just like I showed you in the previous video, dump this solid, which is brilliant blue, into your flask. And it's easier to do it into a dry flask, to be honest. Otherwise, it gets stuck on the sides. And fill it up halfway, swirl to dissolve, and add distilled water. The reason why we add distilled water is that it is purified. Tap water contains a lot of ions like magnesium, calcium, chlorine, especially if you're in a town or a city, and that can interfere with our pure solution. So use distilled water. That way you won't have any impurities in your stock solution. And that, my friends, is how you make a solution. Don't forget to label the flask. Now, typically in the lab, you're going to decant this from the volumetric flask into some container. Now, I don't have a container here, but I have to admit, one of the beautiful sounds to a chemist's ears is the chug, chug, chug of a chemical. So you'll store this briefly once it's dissolved, and then you'll find yourself a stock bottle, usually a plastic bottle, and convert it. So let's end our video with that beautiful sound that is music to a chemist's ears. Here we go. Love that sound. And we're almost there. Okay, so there's about 500 mils, and I've successfully created my solution. Hopefully that made sense. It's a quick introduction to the preparation of solutions. Our next step will be to take our stock solution that we just made and perform some dilutions on it, and that will allow us to have a lot of use with our solution. We can use it for other purposes. Until next time, we'll see you folks around. Take care.